Hello guys, a very happy morning to one of you. And guys, now we are just going to see the strength of material final chapter. Okay, so this will be a final run, and after completing of this, we'll just go and look over the problems. Okay, so without wasting, let us get started. So last one is series of columns. Okay, theories of okay. I think so. You have known about this one. Okay, theories of column. It will zoom a little bit. Okay, theory of column. You can see one thing. It means, for example, I just want to tell this. I'll just show you a picture so you will have a clear cut understanding. Theories of column value SOM. Okay, so you can see I think so you can see this one. So different structure is there. Okay, so you can see while we are applying any kind of stresses, so you can see the bending of each and everything is there. Okay, like this. Okay, I think so you can see this one. So buckling and crushing will occur. So that's why we consider, you can see this one. That's why we consider see this one. So while you are applying any kind of load, it tends to just to it means slide, or it tends to change the cross section area. Okay, so while that's been happening, we are just going to calculate how the stress will act and how each and everything will act. Okay, depending upon that, we are just going to see each and everything. Okay, so first one, you can see a member of structure which carries an axial compression load. Okay, strut. Okay, and if a strut is vertical, it is called as column. Okay, a long slender column becomes unstable when the axial compression force reaches a called critical value. So whenever each and everything, whenever a thing reaches critical value, the load goes inside and the buckling will occur. Okay, if a beam element is undergone compressive load and its length in order of magnitude larger than the other dimension, it is called as columns. Okay, it means one side will be longer. Okay, that's it. Due to its size, its axial displacement is going to be very small compared to the lateral deflection. Okay, called buckling. Buckling does not vary very linearly with load. It occurs suddenly. Okay, it is therefore dangerous. So next one is so much important thing, slenderness ratio. I think so you can see it. The slenderness ratio, you can see the ratio between the length and the least radius of gyration. Least radius of gyration. Okay. So the ratio between the length and the least radius of variation. Okay, and the elastic buckling, you can see buckling with no permanent deformation. Okay, buckling with no elastic buckling is buckling with no permanent deformation. Okay, Euler buckling is only valid for long, and I think you can see this one. So this is the main thing I just try to explain. So what is critical load? So what a value the structure and the equilibrium recorded as the magnitude of the angle. Okay, critical load is the only load for which the structure will be in equilibrium in a disturbed position. At this value, restoring effect of the moment in the spring matches the buckling definitely. So if a critical load is less than PR, then the spring dominates and the structure will remain vertically small disturbance. So whenever the load is so much higher, you can see the buckling, it means happens and unstable condition occur. So because of the large deflection caused by buckling, the least amount of energy I is equal to a k square. Okay, k minimum equal to root of I minimum divided by a. Okay, why I minimum we just took is while the inertia is minimum only, the buckling tends to occur mostly. Okay, so for a Euler's theory, we are just assuming the column is perfectly straight and uniform cross section. The material is homogeneous and isentropic. Okay, I think so. Again, homogeneous means in one side we are just taking the elastic property same, and isentropic means that in that particular point the each and every elastic property is same. Okay, the material behaves elastically. Okay, elastically, the load is perfectly axial and passes through center of the column section. The weight of the column is neglected. Okay, so the main formula is P. This is a critical load. Euler's critical load equal to pi square EI divided by LE square. Okay, this is the main thing. So coming back to this one, you can see theory of column. This one is prismatic bar and the load is applied. Okay, while the load is applied, you can see it means your axial and compression load. It means this is normal thing. Okay, it is called as stress, no bending, no torsion, no others. So but whenever you just take it as vertical only, it is called as column. Okay, cross section area only compression is called as strut. Okay, column, it is a vertical member subject to the axial compression force and cross section remains constant throughout the length. Okay, it is called a short column, and You can see whenever the thing is taken, the area of cross section so much greater. Whenever we apply, it is called as crushing load. Okay, so whenever it is so much thinner, it is called as non-column failure occurs due to buckling. Okay, this thing. So you can see it means while you are just so load changes, beam also changes, and axial load, each and everything. Okay, critical load for buckling is a load for which buckling generally starts. Okay. So compression load, crushing load, and a buckling load, which will happen because it depends on the design. Okay, buckling generally less force needed, 10 kN. Crushing huge force needed. Okay, for design of a member, if subjected, it means the compressive load we have to check the buckling load as well as compressive load. Okay, minimum is definitely minimum cross section area or minimum inertia. The buckling load will generally occur. Okay, so the main formula you can see P critical equal to pi square EI divided by LE square. Okay, this is the critical load. Okay. So you can see this is not injured, it means not injured means just PDL of pi square E I minimum divided by L square. So you can see I minimum of inertia of x, inertia of y, where the minimum as a variable. So circle I x, I y, okay, both same. So rectangle I x, I y, we take the minimum. So where the resistance is less, easily bending moment happens. Okay, I think you can answer. So you can see bending resistance for bending is less, so buckling happens in this direction. Okay, it means whenever the inertia is less, we just going to take over. So you can this one I x is this one so much lesser. So in case of fluid mechanics, you can say the rolling occurs due to the inertia is so much lesser. So the rolling takes place at that moment. Okay. So next one, circle moment of inertia resistance to bending, and in circle I x and I y same. Okay. So next thing, these are the most important thing that you just wanted to have. So you can see whenever both are hinged, it means both are hinged like this. I'll just show you that. Like this it will be. Okay. So I think so you can see it one. So in this side both are fixed. Okay, like this. Okay. So while that's been given, what is the formula? Pi square E minimum E of I minimum of L square. Okay. This is the main formula. So what is next one? If you can see both sides are fixed like this, it means means this is, you can see what is the formula? 4 pi square E of I minimum divided by L square. Okay. So if one side fixed, one side is hinged means you can see 2 pi square E I minimum divided by L square. Okay. So next thing, if only one side is been fixed, another side is free means one side fixed, other side is free means pi square E of I minimum divided by 4 L square. Okay. I think so you are getting the point. Pi square, so this one like this side it goes. Okay. 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 This means depending upon our thing, each and everything changes. Okay. So you can see in this effective length is L. Okay. In this effective length is, it means one side fixed, other side is hinged means effective length is L divided by root 2. Okay. Whenever the both sides are fixed, you can see effective length L equal to L by 2. Okay. So if one side fixed, other side is free, effective length is 2 times of L. Okay. So generally these are the questions that have been given. So questions we will just see later on, but I think so you can see this one. Okay, in this you can see the critical load is twice. Okay, generally this kind of things fails so much quicker, but this kind of things the withholding capacity of critical load is so much higher. Okay, so that's why in the fixed it is so much best. Another one of the thing is the units are so much important. Okay, you can see E what the megapascal is Newton per meter per square, and if initiate take in millimeter square, so length and like that. So depending upon the, it means unit we have to just go on. Okay, because unit is so much important thing, just you want to just note it down. Okay, so next thing you can see about this one. So proof. So you can see load given and buckling happens, slope will occur definitely, but deflection is 0. It means at the end point, you can see at this end point the deflection is 0, but the slope is occurring. Okay, you can see this. So now we are just turning and we are just calculating the y. Okay, while we are just calculating the y, I think so you can see this one. So this is a simple thing. It means m of x equal to minus p of x of y of e of y d square by this one. Okay, while you just this one is p critical of y. So while you just put an integrate, you can see both this equation will come. Okay, so second order differential equation is what? D square by dx square plus k square of y equal to 0. Okay, so k equal to root of p critical of e of y. Okay, so k equal to root of p critical of e of y. Okay, so this is second order differential equation, elastic curve equation, and in the form of y. Suppose you can see if the curve of y equal to e of mf, you need to just go and put here. Okay, and if dy by dx is m e of mx, d square by dx is equal to m square e of mx. So go and put in the main equation, and you can get m equal to plus or minus I of y. So what will be the value? Y equal to e of alpha x a of cos bx plus b of sin bx. Okay, I think so. So this is the main formula, but what is an alpha value? Alpha value is 0. Okay, so this one just goes and tends to 1. So y equal to a cos bx plus b sin of bx. Okay, the deflection tends to be like this. Okay, it depends on the x, each and everything just varies, and we have two constants a and b. Okay, okay, so whenever you can see, whenever y equal to 0, it means at the end point this y equal to 0, you can see this goes. Okay, and it becomes, I think so you're able to understand. Okay, so x equal to 0 and y equal to 0, no deflection happen, and while you put a equal to 0, so deflection y follows b equal to sin of k of x. Okay, so deflection follows sine curve. Okay, y equal to b of sin k of x. Whenever x tends to 1, y tends to 0. This is the equation. Okay, so if buckling is occurred, then sin kl equal to 0 should be not equal to 0. Okay, so this kind of thing occurs at the buckling. Okay, if kl equal to 0, if kl equal to 0, pi, 2 pi, 3 pi, and n pi goes, so k square l square equal to 0 square pi square and 2 pi the whole square, 3 pi the whole square, n of pi the whole square. Okay, so p critical equal to pi square e of I divided by l square. Okay, so I think so you are able to see this one. Okay, so you can see this one, this curve follows the sine curve. You can see here two curves are there. Okay, this one curve is there. So kl equal to 2 pi. Okay, that's the most important thing. Kl equal to 2 pi and k square as well equal to 4 pi square. Since p critical of this one entirely depends on what, you can see this one. It's simple thing is only simple only. So K square equal to P critical divided by E of I. Okay, so K square L square equal to P critical L E the whole square divided by E of I. K square L square equal to pi square 2 pi square 3 pi square like this is on. Okay, so this is you can see K L equal to 2 of I. Okay, so K square L equal to 4 pi square. Okay, just go and put in the equation, you can calculate. So same thing you can see generally here three things is there. So K L equal to 3 pi. Okay, so 3 pi K square L square equal to 3 pi this one. Okay, so generally like this it will be given, and I think I will explain you in the question. Okay, next one is Euler series all. Okay, but how to find whether it is short column or long column? So generally you can see this is crushing load, in this buckling won't occur, but whenever you reduce a cross section like this, the cross section you can see the increase, means this small increase like this we are just going, cross section increases. If like this we are just going, cross section decreases. This thing the entire crushing load will be occur. So reduction of cross section we can to buckling, and you can see I think you can understand. So what is the slenderness ratio is? Slenderness ratio equal to crushing load minus of buckling load. Slenderness ratio equal to crushing load minus, not minus, equal to buckling load. Okay, so crushing load and equal to buckling load is, crushing load is it means sigma c of pi square E of I minimum divided by L square. Okay, sigma c of E equal to pi square E of I minimum. I minimum is what? Area into K square. Okay, divided by L the whole square, area like it cancel, and L square equal to K square minimum equal to pi square E of I entire thing. Okay, so slenderness ratio gamma equal to LE effective length by K minimum. Okay, slenderness ratio equal to LE effective length by K times of minimum. Okay, gamma equal to LE divided by K times of minimum. Okay, equal to pi root of E of sigma c. Okay, okay, you can see if mild ratio is given, gamma it means slenderness ratio greater than, it means greater than 80 means it is buckling. Okay, if slenderness ratio 30 to 40 means it is buckling or crushing, depends on the shape. If it is less than 30, short column, it is crushing. Okay, next one you can see gamma more buckling occurs, gamma less crushing occurs. So that's it. So Rankine formula, he created a formula valid works on both long and short column. Okay, you can see 1 by P of Rankine equal to 1 by P of Euler plus 1 by P of crushing. Okay, 1 by P of Rankine equal to 1 by P of Euler plus 1 by P of crushing. Okay, this is the minimum. For long column you can see, for long column it means crushing is so much higher. Okay, when we compare to the Euler. So you can see, so whenever you just apply the crushing load is so much, and when you divide, you can see the Rankine, it means Rankine will be so much equal to Euler. Okay, 1 by P of Rankine equal to 1 by P of Euler. Okay, this is the most important formula. So next one, whenever you just consider short column, in that short column Euler we generally neglect. So Euler goes for buckling, and it means crushing load goes for crushing. Okay, so on this one, so on P of Rankine equal to P of crushing. Okay, that's it. I think you can understand. So when we just cross multiply, so this entire equation will come. Okay, so this is the Rankine formula. Okay, so Rankine formula equal to sigma c A divided by 1 plus A LE may of K minimum the whole square. Okay, so I think you can understand. So next one, Johnson's parabolic formula. So what is Johnson's? B equal to sigma y of A 1 minus A LE of kingdom. So I think so you can see this one. So this just go and take it upwards and put minus, that's it. Okay, so you can see LE square is also generally it goes to parabolic. Okay, J is Johnson constant, but here A is Rankine constant. So different, just a little bit. So since it is been minus and it's been plus, that's it. So A equal to this entire thing is sigma c pi square of E. But here the 4n will come. Okay, n depends on the hinge condition. Okay, if both are hinged means n equal to 1. Okay, so we can see in this thing, this is crushing load, and you can see Johnson's straight line formula, and you can see Jansen's parabolic formula lies a little bit downward. Okay, and it goes, and you can see here each and everything means the crushing stress tends to be parabolic form. Okay, he said for the stresses will be parabolic. Okay, below this given stress and no failure occurs. It means I think so you can see this one line. So below this mostly the no failure occur, but above definitely the failure occur. Okay, I think so you can understand. So the other formula is, you can see whenever stress is given here it goes like this, but whenever the stress is given here you can see the eccentricity is there. So what will happen? So you can see this will just rotate. It means like this will be and like this will be. Okay, so two types of load is occurring. So here bending also will be. Okay, so you can see PE and the one stress. Okay, this one P will be here of direct stress and as well as the bending stress M by. So here each and everything will be plus, but here it will be minus. So generally there will be a neutral axis. Okay, we don't know the eccentricity. So at that eccentricity the entire thing will be 0. Okay, so you can see, so direct minus PA due to this one, this side. Okay, so no tension or any fiber occurs in one side. Okay, so at the time both will be equal. So P by A equal to M by divided by I. Okay, so it means I think so you can understand. So where that will be same equal to, so M by divided by I. So I equal to what I just did, area into K square. Okay, so calculate, and at this load it means at the eccentricity equal to less than or K square divided by y. Here the eccentricity is low, then only compression will occur. Okay, no tension will be. So no tension will be at this side will be showing. These are the questions that will be asked. Okay. So if you just go for circular cross section, you can see this is eccentricity. If you go for circular cross section less than d by 8. Okay, d by 8. Okay, and you can diameter of canal kernel you can take it E equal to d by 8, same 1 by 4 to 2 equal to d by 8. And whole cross section means you can see E equal to less than or equal to d square capital D square minus plus small d square divided by 8 of capital D. Okay, 8 of capital D. Okay, that's it. Whenever you just go for rectangular cross section, you can see E less than or equal to b by 6. Okay, E less than or equal to b by 6. And when you just go for next thing, it means rhombus, you can see different things there, and third rule is applied, 1 by third rule is applied. Okay, and double eccentricity just goes a little bit different. Okay, right. So springs and I just explained in lateral chapter, so now it doesn't work. Okay, okay guys, then that's it for the video, and I hope you all like, and okay, let me see in the next one. Bye bye.